Hey everyone, today we are looking at section 12.3, which is sector area and arc length. So first thing we're going to talk about is what is a sector. So a sector is a piece of a circle and that comes from that central angle. So when we look at this shaded portion of the circle right here is what we call a sector of a circle. So a piece of pizza is a sector of a circle. All right. If we're finding the area of the circle, remember that an area of a circle is pi r squared. So let's say for a second that this sector, or this angle measure right here in the sector is 90 degrees. It's not, it looks like it's a little more, but we're going to pretend for just a second, and you don't need to write this down, but we're just kind of going to talk through it. So if this is 90 degrees, 90 is a quarter of a circle, all right? So because 90 over 360 is 1/4. So that would make this shaded sector a quarter of the whole circle. So that would mean that I would want a quarter of the whole area. So I would take the area formula and I would multiply it by 1/4 because that's all the circle that I want. I have a portion of my circle, so I want a portion of the area. Well, the way we figured out what portion we want is by we take that degree, which in the case we talked about here was 90, and we divide it by 360. All right. So the way that I find the area of the sector is I take that area formula and I multiply it by the degree over 360. Now, similarly, arc length does the same thing, except in terms of arc length, we are now looking at circumference, which remember is 2 pi r. So if I look at, again, this is nowhere close to 90, so please don't mark this as 90 on your papers, but let's pretend for a second that this was a 90-degree angle, then I would have a quarter of the circle, so I would want a quarter of the circumference. All right? One thing that I want to make sure is very clear here is that there is a difference between the length of an arc and its degree. Let's say for a second that this was 80 degrees because that actually looks a little closer. Again, you don't need to write this. We're just talking through. This could be an 80-degree arc, but its actual length might be 2 feet. So another way we can kind of make this clear is if I take this same picture and I make it bigger. All right. Both of these arcs have an 80-degree angle measure. All right, they measure the same degree, but this arc may be 2 feet and this one may be 5 feet. So the lengths are different, but the degrees are the same because remember, circles are similar, and in similar figures, lengths are different, but degrees stay constant. All right, because it is the same shape, just different sizes. So that is one of the things that's really important that you understand is that the degree of the arc and the length of the arc are different. So length of the arc is measured in feet or inches or centimeters or whatever our unit may be. And then we have our degree, which is obviously measured in degrees. All right. So we're going to do that similar process here. We're going to take our degree, divide it by 360, and then multiply by our circumference. So that is where we are going to start here. All right. We're going to start by taking a look at arc length. So when I look at my formula for arc length, the way that I tend to write it is the measure of the arc over 360. And then we multiply that by, since we're doing arc length, it is 2 pi r, which is our circumference. Now, I write this way, and I write like ARC, like it's an arc, and with the arc symbol over top of it, because in the formula that they give us, they use the m degree, but we use m for so many things. It's slope, it's midpoint, it's all this other stuff. So I tend to write the measure of the arc because number one, it tells us what we're doing, what we're finding, and then it's not something else that we're using m for. So when we look at this problem, I'm going to use AL to stand for arc length. So when I look at this, I'm going to do my degree of my arc, which in this case is 90 degrees over 360. And I'm going to multiply this again by 2 pi r. So I'm going to multiply it by 2, my radius is 10, and times pi. So this is the piece that goes in the calculator. If it is a nice number, like this one happens to be, this is 5 pi, then you can just dump it all in the calculator and it's fine. But we'll do an example over here where if you try to do that, you get a decimal, and I'll show you what I want you to do. All right, so when you put all this in the calculator, we get that it is 5 pi. You can also realize 90 over 360 is 1/4. 2 times 10 is 20, so 1/4 of 20 is 5. All right, then we want this in both terms of pi and the nearest hundredth. So in your calculator, you're going to do 5 times pi. Remember, please use your pi button, not 3.14, as your pi button is going to be more accurate than using 3.14. Only use 3.14 if your directions tell you to. Now, remember that our unit here is feet, because it is a length, not an area. So 5 pi is 5.71 when we round to the nearest hundredth. All right, we're going to do the same thing over here. We have an arc that measures 35 degrees, and our circle has a radius of 3 inches. So again, for our arc length, it's going to be the measure of our degree, which is 35, over 360, times 2, times our radius, times pi. Now, if you put all of this right here in the calculator, you will get a decimal. So then what we're going to do instead is we're going to multiply 35 times 2 times 3, because remember, these are the same as saying over 1. Okay, when we do that, we are going to get 210 over 360 times pi. Now we're just going to reduce this fraction. So the first easy reduction is dividing by 100. And we get 21 over 36. And then when we can divide both top and bottom by 3, we're going to get 7 over 12 pi. And our unit is inches. Okay, we are also going to put this in the calculator. And this is going to give me 1.83 inches when I round to the nearest hundredth. Now, one thing that I want you to know here is that you may see this written as 7 over 12 times pi, or you may see this as written as 7 pi over 12. These are the same thing, okay? You need to be aware of both ways of writing it and recognize that those are indeed the same, all right? I will take either answer, but please know that you may see them both ways, all right? If you have any questions on that, make note of that somewhere now. And let's move on to area of a sector. Okay, when we're looking at area of a sector, again, it is that measure of the arc over 360 times, now we're dealing with area, so we want our area formula, which is pi r squared. Okay, so when we start here, we're finding the area of our sector. So our degree is 80 over 360 times our radius squared, so 3 squared times pi. And when we do 80 over 360 times 9, we are going to get 2 pi. Now, we are in area, so it is inches squared. Then we're going to put 2 times pi in our calculator, so we get this to the nearest hundredth as well. And this is going to be 6.28 inches squared. So those are my two answers. And then we're going to do the same thing over here. The degree of our arc is 120 over 360 times my radius, which is 6 squared times pi. Okay, when I do 120 over 360 and I multiply that by 36, I'm going to get 12 pi, and that is centimeters squared. And when I put this in our calculator and we round to the nearest hundredth, it is going to be 37.70 centimeters squared. So let's talk about this for a second. Okay, this is 37.699 in the calculator. I am rounding to here, so that 9 rounds it up to the 70, okay? It is important, if we are rounding to hundredth, that we have something in that hundredth place if it was rounded. Okay, if you round to a 0, whether you're rounding up like we are in this case, or it was 0.01 and you were rounding down to a 0. All right, then we would still be writing the 0. The only time you do not have to write the 0 if it was exactly 37.7. But when we're dealing with pi, because pi is irrational, we're not going to get that. That's not going to happen in these cases, okay? But you may see that in other cases. So again, if you are rounding and you're rounding something to a 0, you need to write the 0 down to show that it was rounded there. It was not exactly the other number. Okay, so in this case, we don't want to put 37.7 because it was not exactly 37.7. We rounded it there, so we need the 0. All right? Again, any questions, make sure that you make a note. Next thing we're going to talk about is a segment of a circle. So what we're looking at is a segment is this area that is contained by the arc and the chord. So this shaded green area is what we call a segment of a circle. Now, notice that in order to get the segment, I have an entire sector. Okay, so I could shade this whole thing in green to be the sector. And then I have a triangle right here. So I can find the area of the sector, which would cover the whole thing, and then from that I would subtract out the area of the triangle, and then I have what's left over, which would be that segment area. All right, now one thing that's going to help us do this is remembering this formula for area of a triangle, okay, that 1/2 AB sine C. So we did this in chapter 10 when we did area and trig, when that 10-2 part B section, okay? So remember, like if I wanted to find the area of this, I would have 1/2 times 8 times 7 times the sine of 25. All right, that's how we work that out. I'm not going to put it in the calculator. I'm not worried about that, but that's how that would be processed. All right, so when we're looking at this piece, when we're trying to find that area of the triangle, remember your radii are the same length. So if this is 7, then this is 7, and then whatever this degree may be. Okay, we can do 1/2 times the two sides times the sine of that degree. And that will get us the area of the triangle if it's not a nice area. If it's 90, it's really easy to do 1/2 base times height because base and height are the same. But if it's not 90, sometimes it's easier to do this. All right, so let's take a look at an example. So I want to find the area of the segment. So the first thing that I'm going to do is I'm going to find the area of the sector, which is that measure of the arc, over 360, and again, it is area, so we want our area formula, which is pi r squared. All right, so the area of the sector is going to be, my arc is 60 divided by 360, okay, times my radius squared times pi. So when I put that in my calculator, the first part of it, 60 divided by 360 times 144 is going to give me 24 pi. Okay, so this is 24 pi here. Now, there are two ways to get the area of the triangle. Okay, so when we are looking at the area of the triangle, I can use 1/2 base times height. Or I can use 1/2 BC or AB. Guys, just know that it doesn't really matter what letters you put here. AB sine C. Or BC sine A, or AC sine B. It's the two sides and the angle that is included. All right? So if I want to use 1/2 base times height, if I look at my triangle, all right, I know that this is 60 degrees. And I'm told my radius is 12, which makes this piece also 12. Well, I can draw in the height of the triangle here. And I see, oh, that makes this 6. I have a 30, 60, 90 triangle. So the height is going to be 6 times the square root of 3. Because remember, that's the long leg, and it's short times the square root of 3. So I would have 1/2 my base of 12 times my height of 6 root 3. so that the area of the triangle is 36 times the square root of 3. All right, if I was going to simplest radical form, that is the direction I would need to go. But because I'm rounding to the nearest hundredth, remember, if we can go to decimal, then we can use trig. So if we look at our triangle in terms of this piece, I have my 60-degree angle. I know this side is 12, which makes this side 12. Because again, look, they're both radii, so they have to be the same length. All right, so I would have 1/2 12 times 12, and I'm going to run out of room, times the sine of my angle, which is 60. So I put all that in my calculator, and I'm going to get 62.3538. Now, obviously, you don't have to do both of these methods, all right? This, if you put 6 square root of 3 in your calculator, you're going to get this, all right? These are the same. One way or the other, it doesn't matter which, okay? Unless it says simplest radical form instead of hundredth. Okay, if it's simplest radical form, you got to go here. Because remember, we cannot use trig with simplest radical form. I'll say it again. You cannot use trig with simplest radical form. But over here, we have trig because we're going to hundredths. This is usually the easier way to do it. All right? Because you can use that for everything. Again, unless it says simplest radical form. So to find the area of the segment, we're going to take the area of the sector, and from that subtract the area of the triangle. Okay? So the area of the segment is going to be 24 pi minus 62.3538, or 36 square root 3. Notice I'm leaving this longer than hundredths because I'm still in the middle of my problem. All right? I don't want to round too far too soon when I'm in the middle. So the area of my segment, so you're going to do in your calculator, guys, 24 times pi minus this number, okay? Or minus 36 times the square root of 3. Then from here, when we put it in the calculator, we're going to get 13.04. Our unit is inches, and it is area, so it is inches squared. All right? If you have questions, write it down. Again, we're doing the whole sector area. We're going to subtract the triangle out of that, and that's going to leave us that little shaded piece left over. Again, this is usually where we're going to go in terms of finding the area of the triangle. It does tend to be a little easier. All right, so here's what I want you to do. You'll see 3 of them on your paper because I'm going to do the next slide as well. But please go ahead and work out these next 3 problems on your own. All right, and pause your video. When you're done working out your problems, press play, and then we will check them. All right, so go ahead and check your answers. So again, when we're finding arc length, we're doing the measure of the arc time divided by 360 times circumference, so times 2 pi r. When we're doing area of a sector, we're doing that arc over 360 times our area formula, which is pi r squared. All right, so when we're looking at these, just make sure that you are simplifying those fractions, because if you put those in the calculator, like this one, you should have seen 1.3 repeating. Okay, I know that's 4/3, so I didn't worry about going through the simplification process. But one of the things that might be easiest is when we do, you're trying to simplify, you have 40 over 360, simplify this first. Okay, then you have 4 over 36, which is going to simplify to 1/9. Okay, then you can have 1/9 times 2 times 6, which is 12, which is 12 over 9, which is 4/3. Okay, so that is a good way to simplify too. So like if we're looking at here, that 36 over 360 is the same thing as saying 1 over 10. Then we multiply that by 16 squared, which is 256. So we get 256 over 10. and then we divide top and bottom by 2, that's where we get the 128/5. Okay, so reducing that arc over 360 first can help you as well if you're trying to simplify, so that way you don't have very large numbers. Because like if in the second one, if we tried to do 36 times 16 squared, that's going to give us 9,216 over 360. You're still going to go through a process to try to simplify that. All right. So if you have not yet done the third one, go ahead and pause the video and do the third one. And then I will come back here in just a second with your answers to check. All right, so go ahead and check your answer here. If you did not get this, make sure you check each piece. So the area of the sector, again, that's the degree over 360 times pi r squared, because again, we're finding area. So 90 over 360 is 1/4 times 16 is 4. Okay, so our area of our sector is 4 pi. Because it is a 90-degree angle, our base and height are both 4. Okay, if you did not recognize that, you could have done that 1/2 AB sine C. The sine of 90 is 1. All right, so that would end you in the same spot. So again, it doesn't matter which way we go. So we do for our segment is the area of the sector minus the triangle, so 4 pi minus 8. And when we put that in our calculator, we get 4.57. Again, if you have any questions, please let me know when I see you next. Have a wonderful day, you guys, and I'll see you later.